Hey, this is Mr. Janes, and this is part 2 of the special right triangle video. In the first video, we learned about 45, 45, 90 triangles and how every single 45, 45, 90 triangle has sides that are proportional to 1, 1, and the square root of 2. We also learned that every 30, 60, 90 triangle has sides that are proportional to 1, 2, square root of 3. And we use those facts to solve a few problems, both off the notes and on the notes. But occasionally we ended up with answers like this: 5 over the square root of 2, or 10 over the square root of 3. And oftentimes, mathematicians don't like to leave square roots or radicals in the denominator, or the bottom, of a fraction such as the square root of 2, or the square root of 3. And so to solve that problem, what we're going to do is, if we end up with a square root or radical in the denominator, we're going to do something called rationalizing. Remember that square roots or radicals are called irrational numbers, which means that they cannot be expressed as a fraction. If we put them in our calculator, we would get a long decimal that never repeated, and it's quite messy to work with. So instead of leaving this square root in the denominator, we're going to rationalize it. Here's how we do that. The trick is to multiply both the top and the bottom, or the numerator and the denominator, of a fraction by the root that's in the bottom, right? The square root of 11. Here's why. In the top, nothing too exciting happens. 3 times the square root of 11 is 3 square root of 11. Nothing too exciting. But in the bottom, in the denominator, the square root of 11 times the square root of 11 is the square root of 121. And just so happens the square root of 121 is 11. So this ends up being 3 square root of 11 over 11, which is good because there's no longer a square root in the denominator. Now it's just a whole number, 11. We could do the same thing with this one right here, 12 over the square root of 18. To rationalize, I'll multiply the top and bottom by the square root of 18. And we get on the top 12 times the square root of 18. And in the denominator, we get the square root of 324, which, as you may have guessed, is actually 18. And in the numerator, we get 12 times the square root of 18. But looking out for this, the square root of 18 isn't simplified all the way. And so the square root of 18 can actually be broken down into the square root of 9 times the square root of 2, which means that this could be really written as 3 square root 2. And 3 times 12 gives us 36. So really the numerator could be written as 36 times the square root of 2, and the denominator is 18. Then at the very end, we notice that we've got 36 over 18, and that fraction can be simplified a little bit. 36 over 18, if we divide the top and the bottom by 18, we actually get 2 over 1, or just 2. So this is equal to 2 square root 2. So generally, when you see a radical or a square root in your denominator, you want to try and rationalize by multiplying by that radical again. You should get no more radical in the denominator, but make sure you simplify whatever's in the numerator, and then, if possible, simplify the fraction further, such as 36 over 18 equaling 2 square root 2. At this point, pause the video and try and rationalize and simplify 4 over the square root of 5, 8 over the square root of 24, and go ahead and rationalize the two answers from above, the 5 over the square root of 2 and the 10 over the square root of 3. Pause the video now. The answers are coming in 3, 2, 1. In this first problem, we rationalize by multiplying the top and the bottom by the square root of 5. In the numerator, we get 4 times the square root of 5, and in the denominator, we get the square root of 25, which of course is just 5. And there is our answer right there. In the second one, we're going to rationalize by multiplying the top and the bottom, numerator and denominator, by the square root of 24. And so in the numerator, we get 8 times the square root of 24, and in the denominator, we get the square root of 576. 8 square root of 24 by pulling out the square root of 4, which is 2, and we're left with 16 square root of 6, and the square root of 576 is exactly 24. But we're not done yet. Look, 16 over 24, we can simplify that numerator and denominator by dividing both by 8. So instead of 16 over 24 square root of 6, we have 2 square root of 6 over 3. Lastly, if you're trying to rationalize our two answers from up above, let's see what we get here. This first one, x ends up being 5 square root 2 over 2. And the second one, by multiplying the top and bottom by the square root of 3, we end up getting 10 square root 3 over 3 after rationalizing. Now that you've learned a little more about rationalizing, go ahead and try and solve these last 4 problems. Before we start, it might be useful to just copy down the special right triangles that we worked with so far. So we've got the 45, 45, 90 triangle, and that has sides 1, 1, and square root 2. And we've got the 30, 60, 90 triangle. Okay, there's 60, there's our 30. And that's got sides 1, 2, and square root 3. So now that I've got those down as hints to help me out, go ahead, pause the video now, and try 1, 2, 3, and 4. The answers will start coming up in 3, 2, 1. All right, let's go with the first one. First one is definitely a 45, 45, 90 triangle. So we're going to relate to this triangle right here. And so the longest side here is 3 square root 2, crossing the 90-degree angle, and that corresponds to the square root 2 side here. So how do you get from the square root of 2 to 3 square root of 2? Well, it looks like you're multiplying by 3. And so from 1 to the x, multiplying by 3, so x is 3. And from 1 to y, we're multiplying by 3, so y is also 3. I mean, again, the 45, 45, 90 triangle is always isosceles, so these two sides will be congruent anyway. All right, number 2. Number 2, let's see here. We've got a 45, 45, 90 triangle again, so we're going to look at this first one again. And so it looks like, what does 7 correspond to? Well, 7 corresponds to the square root of 2. How do I get from the square root of 2 to 7 by multiplying or dividing? I don't know. So what I'm going to do is just set up a little ratio for myself here. So the square root of 2 goes to 7. And let's go to v first. 1 to v. Let's see. 1 times 7 is 7. The square root of 2 times v is v times the square root of 2. Divide by the square root of 2 here. And v equals 7 divided by the square root of 2. Except it's not rationalized. We've got a square root in the denominator. So to rationalize it, we'll take 7 square root of 2, and multiply the top and the bottom, the numerator and the denominator, by the square root of 2. So 7 square root of 2 on the numerator, and the square root of 2 times the square root of 2, which is the square root of 4, and the square root of 4 is just 2. So just to see the middle step, that's going to be the square root of 4, which is just 2. So turns out that v is 7 square root 2 over 2. And since this is an isosceles triangle, as all 45, 45, 90s are, this is also 7 square root of 2 over 2. So that is u and v. Moving on to number 3 now, let's take a look. 3 is a 60, let's see, it's going to be a 30, 60, 90 triangle if I fill in that missing angle, which means it's going to correspond to this second triangle we have up here. This 5 corresponds to the one side because they're both across from that 30-degree angle, okay, across the 30-degree angle. So from 1 to 5, we are multiplying by 5, and so all the other sides will follow that ratio. So 2 to x, that means x is going to be 10, multiplying by 5. And the square root of 3 goes with y. Square root of 3 times 5 is 5 square root of 3. So our sides are 5, 10, 5 square root of 3. That's that typical 30, 60, 90 pattern that we've been seeing. And we actually saw this problem on the last video too. Number 4. We're going to need a little bit of extra room for 4, so I erased some of my work. But don't erase yours, just find some extra space in your paper. Please don't erase any of your work. So let's look at 4 again. So 4, we got 90, 60, this is going to be 30. So we got 30, 60, 90 triangle, which means it's going to be similar or proportional to this second triangle we've drawn up here. So our 5 square root of 2 side corresponds to the square root of 3 side because they're both across from that 60-degree angle. I know that. So how do I get from the square root of 3 to 5 square root of 2? I have no idea how that happens. So we're going to have to write out a full similarity proportion here. So 5 square root of 2 matches up with the square root of 3. Okay. Now let's go for n first. N is going to match up with 1. And so 1 times 5 square root of 2 is 5 square root of 2. N times the square root of 3 is square root of 3 times n. Divide them both by the square root of 3 to get n by itself. And we get n equaling 5 square root 2 over the square root of 3. And again, we've got a slight issue there because we've got this radical in the denominator, so let's rationalize that. 5 square root 2 over the square root of 3, multiply the top and the bottom by the square root of 3, and we end up with 5 square root 6 over 3, and that's as far as we can take it. No other simplifying that can happen there. So n is going to be 5 square root 6 over 3. M, remember, corresponds to this 2 side, which is going to be double the length of this. So if this is 5 square root 3 over 3, this will have to be 10 square root 3 over 3. Hope that you've learned a little bit about these special right triangles. Really, all you need to do is just remember these two special right triangles, the 45, 45, 90, and the 36, 90, and their sides, 1, 1 square root 2, 1, 2 square root 3, and use those and a little bit of facts about similarity to solve for the missing sides in any 45, 45, 90 or 30, 60, 90 triangle that you might see. Make sure you've taken notes and are ready for the video check. Good luck.